In this video, we're going to look at two more organic functional groups. We'll look at aldehydes and ketones. But before we look at either aldehydes or ketones, we need to talk about what a carbonyl group is. Now, a carbonyl group is not a separate functional group, but it is a structure that is found in several different functional groups, and it is part of the aldehyde and ketone functional group. Now, a carbonyl group is a carbon double bonded to an oxygen. Now, carbon makes 4 bonds, and so the other 2 bonds that carbon makes in this carbonyl group is going to determine what functional group it is part of. Now, the other thing to know about the carbonyl group is that it is a polar group. The oxygen has a partial negative charge. The carbon has a partial positive charge. And so that fact that it is a polar group is going to affect the solubility of molecules that contain that carbonyl group or in it. Let's look at aldehydes. Aldehydes contain that carbonyl group, and in an aldehyde, a hydrogen is going to be bonded to that carbonyl group. And so let's look at this first molecule here. I'm going to circle the functional group for an aldehyde. You have a carbonyl bonding to at least a hydrogen on one side. This first one that I just highlighted the aldehyde functional group in, the IUPAC name for it is methanal because it contains just one carbon. Now you'll notice that one carbon is that carbonyl carbon, and so when we count the carbons in aldehydes, we do count the carbonyl carbons, and those are always going to be carbon number 1. They're always going to be at the end because it has a hydrogen on the other side, not a carbon, and so those will always be carbon number 1 in aldehydes. The common name for that first one listed there is formaldehyde, so that should be something that is fairly common to have heard before. Moving on, we have ethanal, which has 2 carbons. And so you have the prefix that means 2 carbons, and our aldehydes, the IUPAC name for it is going to have an AL ending to it. The common name for that is acetaldehyde. Now the last one that I have listed there is benzaldehyde, where we have a benzene ring, and so it is named with that prefix benz and then the aldehyde. So it's a benzene ring that is attached to that aldehyde functional group, the carbonyl bonding to a hydrogen. Now, I mentioned before that the carbonyl group is polar and that affects solubility. And so small aldehydes, 4 carbons and less, are going to be soluble in water. Let's look at ketones. Ketones have a carbonyl carbon that is bonded to carbons on both sides. So unlike aldehydes where it had a hydrogen on one side, a ketone has carbons on both sides. So here's my here's my carbonyl functional group, and you'll notice there's a carbon on both sides of it. And so that is what makes it a ketone. And again, these, and then of course you have this other one where you have the carbonyl here, and then you have carbon groups on both sides. But directly bonding to that carbonyl is a carbon on both sides of it, which makes it a ketone. Has that carbonyl group in there, and so it's going to affect the solubility as well. So just like with aldehydes, ketones that have 4 carbons or less are going to be soluble in water. So ketones have carbons on both sides of that carbonyl. Aldehydes have a hydrogen bonding to at least one side of that carbonyl.